Well, the next question says, question C says as proof that b minus a in the brackets to raise to the power of 2 equals to a minus b within the bracket to the power of 2. Well, let's just move this a little bit up there. See question 1. We have like b minus a raised to the power of 2. We need to prove, when they say the question says prove that, it means it is true. We just need to tell why it is true. Now, first of all, I would like to remind you that these principles of one of the law of exponents, when the power is even, okay, the answer will always be positive regardless of the base. I'll give an example first. If I do like -2 within the bracket like that, if the power is like 2, 4, or 6 even power, the answer will be positive 4, okay? It's the same thing as if it was 2 to the power of 2, okay, which is completely different than having like -2 to the power of 2, because this is equal to -4, okay? So just an idea. Now, just note that when the power is even, the answer will always be positive regardless of the base. B minus A can be written as, I'm gonna write it this way. I think I need to introduce the square brackets. I can take -1 out as the common factor of A and B, of B and A, okay? I can take the -1 out, and then in the bracket it will be B, excuse me, it will be A minus B, okay? Now, the power of 2 for the -1, it's gonna be like +1, so it's like 1, and then A minus B to the power of 2 equals to A minus B to the power of 2. Left hand side equal to right hand side. Okay? Proven. Understand? So I take the negative out, so it's like -1, like this to the power of 2, and then the power of 2, -1, -1 to the power of 2 will be +1, and then the power of 2, because the law says that A times B to the power of M equal to A to the M times B to the M. Okay, so this power of 2 will be on -1, which is +1, the power of 2 on A minus B also. Okay, and then the question says, hence, question 2, hence prove by means of factorization that x open bracket x minus 3 raised to the power of 2 minus 3 open bracket 3 minus x close bracket to the power of 2 equal to x minus 3 within the bracket to the power of 3. So I'm gonna write it here. My question 2, x open bracket x minus 3 to the power of 2 minus 3 open bracket 3 minus x to the power of 2 equal to x minus 3 to the power of 2. All right. We did prove that b minus a to the power of 2 is the same thing as a minus b to the power of 2. So we can apply this because here they say hence. So we're looking at what we did before. Okay. So now this, we can apply it over here. It's going to be like x minus 3 to the power of 2 minus 3. Over here, we can write it x minus 3 to the power of 2. Okay, because these two are common, are the same when they are raised to the power of 2. Okay, we can do that, and this will be equal to x minus 3 to the power of 2. Now, we can notice that we have like common factors here, x minus 3 to the power of 2. So we can take it as a common factor, x minus 3 to the power of 2, and then we have left with what? X minus 3. So there is going to be x minus 3 equal to x minus 3 to the power of 2. Now, remember this law of exponents. If you have like a to the m times a to the n, this is equal to a to the m plus n. Okay, there we have like an invisible exponent of 1. So because the bases are common, are the same, we can just add the exponent. This makes x minus 3 raised to the power of 2 plus 1, which is 3. I meant to write 3 there. X minus 3 to the power of 3. So left hand side equal to right hand side. Proven. Thank you. Well, another question here says, consider, excuse me, the expression x squared open bracket x plus 3 close bracket minus x minus 3 close bracket. Show how the method of factorizing the expression is different from the method of expanding and simplifying. I believe here factorization will be the best option, I mean the quicker option. So if I do like in this question D, we have like x squared open bracket x plus 3 minus x plus 3 there. If I factorize, I'll take, you see, x plus 3 there will be the common factor. So this will be equal to I'll take it as the common factor. Okay, let's just write x plus 3 factor of x squared minus 1, because when we take this out as common factor, 1 remains there. There's an invisible 1 here. Okay, there's invisible 1 here. So x squared minus 1, and then this will be equal to x plus 3, and then 1. Note that 1 is same as 1 squared. Okay, it's a square of 1, so this can be written as x minus 1 and then x plus 1, difference of 2 squares. Okay, now expanding will be, expanding and simplification will be like, because it was x squared open bracket x plus 3 close bracket minus x minus 3, this will be we will do like x squared times x squared times 3, and then there we say there's a negative, it's a negative 1 there, so it's going to be like negative 1 times x and negative 1 times negative 3, and this will be like x cubed plus 3x squared minus x and then plus 3. Okay, we expand, and then let's see, can we simplify here? We cannot simplify the like terms, but we can group. Okay, factorize by grouping. So we can take the first 2 and the last 2. Here x squared will be the common factor, and there negative 1 will be the common factor. What? We're coming back to what we did earlier. Okay, nope, not exactly that. Okay, fine. Because if I factorize one, I get this one, and then yeah, that's the difference between the two. Exactly. So the method of factorization gives me the product. The method of expanding and simplifying gives me this sum. Yes, that's what the question meant. That's to do. Okay, thank you.